Okay, so what are the transformations? Okay, so you should be writing all of that on your graph paper because we're doing some extra notes since the notes last night were silent. We just want to make sure that we understand the stuff that I went over in the notes last night. We are going to also find the vertex. Anyone remember how to find the vertex? Yeah, positive 1, 4. Okay, so we're going to go ahead and graph this. So go ahead and get your calculator. So I know that the vertex is right 1 up 4. There's the vertex. And then I'm going to go ahead and take my calculator and I'm going to hit second graph. And 1, 4 is right in the middle. 1, 4 is right in the middle. So now I can see that symmetry because I know this is going to be the same on each side. Henry, are you looking up here? Are you lying because you were just talking to Jason? Yes, you were mouthing words to him. I see you, sir. I see you. All right, so we have the point 1, 4. We have the point 0, 2, and 2, 2. So 0, 2, and 2, 2. So go ahead and graph those. We graphing? You already done graphing? Oh. 3, negative 4, negative 1, negative 4. All right, so there's our parabola. When you're done drawing it, hold up your paper so I can see that you drew it. Let me see those papers. Hold it up, hold it up. Oh, liars, the lot of you tell me you already graphed it. Wait, that looks like a straight line. U shape, U shape, U shape, U shape, U shape, U shape. Yes, yes. Henry, where's yours? Is that a U shape or a V shape? Yeah, make sure it's U shape. All right. All right, what are some things that I always ask you to find? Domain and range. So make sure it's U, not a V. That looks like a V to me. There we go, perfect. All right, domain and range. So on here, these are very similar to the absolute value graphs because a U and a V are like very similar shapes, right? So the domain is still going to be negative infinity to infinity for every single problem because if you look here, there's no x values that get skipped. This graph goes left forever, this graph goes right forever. If you ever ask me if there's a number that I can't square, the answer is no. Like you can take any number you want and multiply it by itself. Negative 5 can be multiplied by itself. 3.12 can be multiplied by itself. Pi can be multiplied by itself. Every number can. So for our domain, we're going to say negative infinity to positive infinity, and that is going to be the answer every single time. Okay? For the range, we look at the bottom of the graph, which is arrows. So what should I put for that? Close. Negative infinity. And then what y value do we have at the top? 4. So we're going to say negative infinity to 4. What should I put around the 4? A bracket. Okay. What else do we typically find? The x and the y-intercepts. So I have an x-intercept over here and an x-intercept right there, and I have a y-intercept here. So I'm going to go ahead and look at my calculator. And what do I do on my calculator to find the intercepts? Second trace, number 2. So second trace number 2 is going to find our x-intercepts. I should see everyone with a calculator in their hand because you're all doing this. So I've got my left bound, press enter. I got my right bound, press enter. The guess is always going to be stupid, so I press enter one more time. I'm hiding the answer from you. So go ahead and find it on your calculator. Write it down. Go ahead and find it. Write it down. I'm hiding it because you guys will use me as your calculator, and I'm not your calculator. All right, go ahead and find the other one. There is one behind my desk. I charged it yesterday. It's against the wall on top of the binders. Do you see it? Yes, that one's all charged up and ready to go. All right, go ahead and write down your second x-intercept. That one doesn't have a cover. Yeah. All right, show your x-intercepts to the person at your table. Show them to the other people. Show them, show them, show them. What'd you get? What'd you get? Oh, calling him out. Jackson, get your x-intercepts. Go ahead and get your y-intercept. Write it down. Make sure the people, so that means your left and your right you probably mixed up. Well, it's hard on these because you're kind of going up and down instead of left and right, and sometimes it's easy to get the wrong one. All right. Did you guys compare with people at your table? Okay. So these are what your x-intercepts should have been: negative 0.414 and positive 2.414. The y-intercept you don't even need the calculator for because you can see it. It's 0.2. Okay. So we got the x-intercept, we got the y-intercept. What else do we typically look for? The max and min. All right, so max, min. What do we notice about this graph? There's no minimum, none. It just goes down forever. And then what's the maximum? And we write it like a point, so what's the point? Close. 1, 1, 4. Okay. So the vertex is the maximum. So just like when we did the absolute value graphs, the vertex is going to be the max or the min, not both. It's going to be one or the other. Okay. What else do we look for? What else do we look for? Increase and decrease. Okay. We want to see where the graph is slanted up, and we want to see where the graph is slanted down. So I put my little stick figure right here. And what is he doing first? Climbing up, so he's increasing. And what x value does he hit right here? X value, 1. And after he hits the 1, what does he do? Decrease, okay. What is the x value of a left arrow? Left arrow, negative infinity. What is the x value of a right arrow? Infinity. Okay, so the increasing interval is what? Negative infinity to 1, because we always go from left to right. We go from down to up. So negative infinity to 1. And then what is the decreasing interval? 1 to infinity. We're going left to right. So whenever you write your increasing and decreasing, you're always going to do the smaller number first and then the bigger number. Negative infinity is smaller than 1 because it's very, very negative. Okay, so those are all the normal things. Then on the video notes last night, I added something new. I added 2 new things. One of them was to describe whether or not the graph is continuous. All right, so the question we're going to ask ourselves each time is it continuous? And the way that you know if something is continuous is if you can start at one end and trace it with your finger without picking up your finger. So, and most of these graphs we've looked at are going to be continuous. It is typical for us at the stage of Math 3 to look at continuous graphs. When you get to calculus, most of your graphs are not continuous. But in Math 3, since you guys are kind of early on into the advanced math portion of like your math career, we still look at pretty simple things. So if you start here and you trace it, you'll notice it's continuous, and that's going to be the answer for most of your problems, okay? So it's kind of a silly question to ask, but we're going to get used to asking it. All right, the last thing was the end behavior, and I'm going to assume you guys have no stinking clue because you didn't hear any sound in the video, right? Okay. Yes, okay, so here's what I want you to draw. I'm going to go through this again, all right? So if we look at a coordinate axis and we're talking left to right, left is a negative infinity, right is a positive infinity, right? If we go down and up, down is a negative infinity and up is a positive infinity. So whenever we look at the arrows of a parabola, they always have 2 things they're describing. They're telling you if they go left and right. The arrow's either going to go left or right, or it's going to go up and down, and it's going to have both of those at the same time. So if you look at this arrow, this is on the left side of our picture, so the arrow goes left, which is how we said negative infinity for increasing. But this arrow is also pointing down. So we're going to say it's a left negative infinity, and it's also a down negative infinity at the same time. Does that make sense? Left and down. The other arrow goes to the right, so that's a positive infinity. But it goes down, so it's also a negative infinity. It's a positive infinity for x, it's a negative infinity for y, okay? So when you write the end behavior, you are writing in formal math notation what the arrows do. Formal math notation, you're saying what the arrows are doing. So we're gonna say as x goes to the left, but we're doing it in formal math notation, which is why we say infinity. The y value goes down. As x goes to the left, y goes down. But we're writing it formal. As x goes to the right, y still goes down. Okay, so as x goes to the left, y goes down. As x goes to the right, y goes down. Okay, does that make sense? All right, so whenever you're writing your end behavior, you're always going to put these 2 parts. You're always going to say, look at the left and look at the right. And for a parabola, you're either going to say down, down, or you're going to say up, up, because parabolas either have both ends going up or both ends going down. So these answers, although they look tricky, they're very easy to find. Okay, down, down, or up, up. How do you guys feel about that now? Looks a little weird, but we can kind of see it. Okay, so we're going to do another example. We're just going to look at the end behavior of a parabola that goes up. So go ahead and label this as example 1. Example 2, we're going to say we have y equals x plus 1 squared minus 4. I have the same numbers, I just changed them. Okay, so all I'm going to do is find the end behavior. So I don't have to do very much if that's all I want to do. So does this parabola go up or does this parabola go down? Well, it shifts down, but does it open up or does it open down? It opens up. So the parabola looks like this. So if we were writing the end behavior, we're going to say as x goes to the left, as x goes to the right, those are the 2 places I look. As x goes to the left, what is the y arrow doing? It's going up, so we're going to say y goes up. As x goes to the right, what is the arrow doing? Going up, so y is going up. So if the graph looks like this, you're going to say as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to negative infinity. So that's one situation. The other situation is this. As x goes to negative infinity, y goes to positive. As x goes to positive infinity, y still goes to positive. Those are the only two possible answers you can have for today. All right. And these are the exact same possible answers you would have had last unit because we were doing V-shaped graphs last unit. Okay. All right, go ahead and switch over to that packet that's in front of you. So the packet is just having you practice all these different things that we know how to do, but in the context of quadratics instead of the context of absolute values. This is going to feel very similar. So number one, they're asking you to find the vertex and the transformations. So what should I write for number one? We have a 5/3 in the front. What does that mean? Okay, vertical stretch of 5/3. What else do we have? Right 5. Okay, and then what is the vertex? Yeah, 5, 0. So positive 5, 0. Okay, so that's all you have to do for number one. There were some people when we took that last test, when it said find the transformations, some people were just telling me the domain, the range, the increasing, the decreasing, the max, the min, the x-intercepts, the y-intercepts. They gave me all that information and I gave them a 0. Because what are all those things? The not transformations. Those are characteristics of the graph. Those are things that are true about the graph. But when I ask for transformations, I'm asking for words that describe that it went left or right or that it stretched or compressed. So you need to understand what the word transformations means and what it's asking for, because you're not going to get credit for giving me a lot of wrong answers, even though if they're like true for the problem. So it's like, yeah, those were all true things for that parabola, but that wasn't what I was asking about. Okay. All right. We're comfortable with graphing. We know how to do that. What do we do? Plug it in the calculator. It's helpful for you to know where the vertex is because it helps you know where to look on your calculator. So what's the vertex for number 4? -5, 7. So then when we graph this on a calculator, that means that on the table we're going to look for -5 because -5 is going to be the very middle. So the vertex is helpful because it tells us where to look. So if I look right here, I'm not around -5. I'm finding all these really terrible values to graph that are like way too small. They're way too negative. But if I go back and look at -5, then I can see this is the middle. And then I can see the symmetry on either side. And it makes it easier to graph. So it's going to be good for you to find your vertex first because it shows you where to look on the table. Okay? All right, any questions before you guys get started? You got it? Answer keys on the board already, so you're welcome to check that as you go. On the next couple pages, just pay attention to the instructions because I don't ask you to do everything for each problem. So like the first section only wants domain and range and max and min. That's all it wants, okay? Increasing and decreasing and intercept. So it only wants a couple things. If I was you, I would draw just a little sketch of this. So if we look at number 8, should the sketch of our parabola open up or should it open down? Should open up. Okay. What's the vertex of our parabola? 1, 1. Okay. So if we go through and answer the questions, we have to know the domain and the range. So for number 8, what's the domain? Negative infinity to positive infinity. And for range, we're going to go from down to up. How far down does the graph go? You can tell from the vertex, right? You look at the y-coordinate of the vertex, and that's how far down this one goes. So it goes down to 1 at the very lowest. How far up does it go? We have arrows. Infinity. Okay, and then what do I put around those? Bracket and parenthesis, okay? Is this a max or a min? A min. So for max, I'm going to put none. And for min, I'm going to put 1, 1. So I didn't have to graph that on my calculator to do it, and I didn't have to do very much drawing by hand to do it either, okay? So this is a good way for you to do domain and range. It's a good way for you to do the increasing and decreasing intervals. It's a good way for you to do your end behavior and your continuity. The only thing that you would really have to graph on your calculator to find would be on the first page when you're completely graphing it, or if you're asked for the x and the y intercepts, then you have to graph it on your calculator to find it, okay? All right, go ahead and get started.